Hello everybody, welcome back to the training of the M172 controller. In this part, we are going to continue with the software. Okay, in the previous mode, we have seen the configuration tab, and now we're going to focus on the programming tab. In the programming tab, we're going to see an overview of this part of the platform. We're going to focus on the toolbars. We're going to see the different poles that we have, the different tasks, and finally, the last variables that we don't see in the previous model, local and global variables. So this is the overview of the software. Just proceed with this. We have the resources where we have all the POUs and the different tasks and local and global variables to visualize, and the variables from the configuration also that we're going to see later. We have the part that we're going to see, we're going to program the code for the PLC. We are able also to see the watch, which is actually a tool where we can see the actual value of the variables. This is good for debugging. A property windows that we can see the properties of the function block that we're going to use. The library tree, all the libraries that comes with the software, and the ones that you create also. We have the output where we see the status when we are connected to the controller or where we compile the project. We also have operators and blocks. There are standard function blocks and additional information of the system. And in the bottom, we see here the status bar. Status bar, we see in this example that, that we have the edit mode, or we can see debug, and connected. Basically, it says the status of the project and if we are connected to the controller or not. In order to explain this a little bit much better, let's go to the software. In the previous part, I explained to you how to manage the projects. See everything in this model. If we open this, okay, I will open the installer, but I don't want to use that, and I want to go directly to the project. So I'm going to use this one to open not the Machine Expert installer, just the project for the EcoStruxure Machine Expert HVAC. See here, configuration and programming. So this is the project, the resources, the library tree. Okay, we can enable here to not disappear the watch that is only available to see the actual status when we are connected to the controller. The property windows. At the bottom, we can see operators and blocks, the outputs. In this part, in the bottom, we can see edit. This part is to compare the code of the controller, and this one if we are connected or not. So, if we are not able to see anything like this, the watch or library tree, we need to go to View, select Tool Windows, and then enable what we want to see. See, here I have disabled the operators and standard blocks. Now it's enabled again. And for this one, okay, View, Tool, we have the toolbars, which is good to have everything, okay? And then we can just drag and configure the visualization that we want. So let's continue with the presentation. This is what I told you before, okay, how to enable these tool windows. This is the part of the output where we can see the status when we build the project, okay, or we are connected to the controller. The status bar, okay, this is the messages that we can see if we are not connected, if we are error, or we are connected, okay. This is usually when we remove the cable or remove the power supply when we are connected. This is the status of the source code. What we do here is the software can check the code from the controller and your application. If everything is good, we have the source OK. If the application is empty, we have no code there. And here is the debug and edit mode. If we are connected to the controller and the source is OK, we can go to the debug mode and see the real change of the variables in there. Now, in the watch, there is a lot of options here, but basically what we need to do is to drag and drop the variables, okay, that we're going to see later, and see how it changed the real value. There's nothing special. What is good to know is here in operator and blocks that we have all the function block that we need, the basic ones. So let me show you much better. Here at the bottom, operators and blocks. We have operators and standard blocks, target variables. Okay, they are more related to the BIOS parameters, and target blocks. Mode 10 are for Modbus, and syswrite are related to write a new value to the EEPROM. So something important I missed, that we are not able to write in the software directly to the EEPROM, so we need to use this function block. Okay, and to see more information about this function block, right click on it, object properties, property window. Here we can see how we should be using this function block. So we also have another view for this. If we make right click, view folder, we can easily identify the function blocks. For example, if I want to use an add, arithmetic, an add function. Okay, it's quite simple. And if I want to use a dedicated function block, we can go here, library tree. For example, basic. If we want to use timer, on object properties, property windows, and see more information about this function block. We have triggers, okay, and if we go to application and use a PID, we go to, no, this was not, regulation and control, PID advanced, object properties, and we can see here all the definitions of the inputs and outputs of this function block. Let's continue with this. This is the library. For more information about the complete library use, this is the link to download the file. So we also have the possibility to see the oscilloscope. Okay, it's quite good to see the control and adjust the PID if you want to use it. I believe by default it's not enabled. Okay, so what you need to do, view, tool windows, oscilloscope. There we go. And in order to make modifications, we need to be online, okay, to get access to this information and play with it. All these tools, okay, for the just the visualization to the oscilloscope and all the values. This is the sampling and all the stuff. But something good here is when we see the variables, we can export the file, okay, and see this visualization on the Excel, which is good to analyze. So the toolbars. This is all the toolbars available when we are programming. It depends on the language we are able to use it or not. Okay, the main, the projects, the debug, okay, FPD, ladder, and network. So for me, it's always good to enable all the toolbars so we can easily access to the function that we want to use. So in this case, let me just explain a little bit further. If we want to connect function blocks, we use this. If you want to use the variable to the watch, we use this icon. If you want to call a new function block, we use this. If you want to call a variable, we can use this. If you want to call a constant, we use this symbol. If you want to create a return or a jump, we use this symbol. If you want to comment this one, if we want to add more or less input, we use one of this. If you want to use the enable and enable output, we use this symbol, as you can see here. And if we want to add or remove this symbol. So properties and view source. But let me just explain you how this can work. So if you can see here, this is a structured test. So some functionalities are not enabled because it's a different block. Let me just create a new bow. Okay. In this case, I'm going to create blocks. Shape example. Oh, I forgot. Need to change this. There we go. I need to assign to a task. So you can see here is enable. Variable click. We need to define is input output. Input if it's constant. This. Okay. Double click on it and we can select decimal, boolean, true, false. If you want to command hello, we see the comment here. If you want to new function block, we can see all the functions in here. We can filter, or another way is to drag and drop. Simple as that. For example, add. If I want to use more I use, just click. If I want to reduce this one, enable output. There we go. And for this one, the offset properties. Okay. Source view, and there's the other one. In this case, is not available. We cannot enter on this one. So let's continue with the presentation. Okay. We also have the function to find a project. Okay, find a project, and we see in the output the result, and if we click on it, we can go to the part of the code. So this is the different language that we have: the graph set, the structured test, the ladder, and the function block. So which language is better? This is a good question, and the answer, it depends on what we want to do. Sometimes it's much better the structured test, sometimes ladder, sometimes function blocks. It depends. But what we need to do, what we need to know is that we can work with all of them in different POUs. Okay, that is good. So how we create a POU? Okay, first we need to know that there are three different POUs here: the program, the function block, and the function. Let me show you a little bit more about this. So just delete this one. Okay, good. So I have already created a POU, but let me just delete again. Good. If we go to the project, add, we see new program, new function block, and new function. So in this case, I'm going to create a new program. Again, the test. The program must be assigned to a task to be executed. Okay, and then we have the functions. For example, the function block can be this one. Okay, any of this one. For example, let's just add again. And then we have the function blocks. For example, timer. Here, the function blocks, this type of function block need an instance, a position, a memory position in our software, in our program. So instance Tion. You will see here the difference. Tion has this variable. In this case, have located as a local variable, and this one doesn't require anything else, just the input and output, and that's all. In this case, with the function block, it requires some previous status. Okay, so that's why we need to use the instance here. We can create our own functions and our own function blocks. Add new function. We need to define the language that we want to work with, name, and then the function block. Again, the language and the name. Later we're gonna see an example how we can work with this. So don't worry. So this is what I told you. If we create a POU, it is created and we need to call it in a task to be executed, in this case in the time, and we can create local variables in there. Okay, in order to create local variables in a POU as program or function block, what we need to do, I forgot to tell you that, is to go to the right part, local variables, and use this symbol, insert record and the date. Okay, in case we're going to use a function block, new Theon, for example, no, you need to insert the record, okay, and then in the class you need to define if that variable is internal only or is var input, var output, okay. So you can see here like this, and also the pin. So this is how we can create the POU, already explained that. And if we forgot to call the variable, the program, we just right click on the task and add the program. You will see all the POUs that you have. So I have explained how to create the POUs, the program type, and now what we need to know is the different tasks that we have in the controller. So we have boot, init, time, modbus, and background. As you can see here in the project, task, time, background, boot, init. But what happened here? The modbus task is missing, and that is because the M172 don't have that type of task. It is only for the TN172, for the TN171, not for this performance one. So the boot, it only executes only when the system starts up. For example, if I want to create an alarm that indicates that the controller has been energized, we just, run software. We just need to, for example, create a POU, for example, ladder init, and assign to the init. And here we can make the code, for example, alarm, execute alarm, or something like that. Everything, or for the initial configuration, something. Everything that you need to be executed when the PLC start up, you can be executing here. And then we have init, for example. This is good when we want to make a download the project, okay, and we want to predefine some initial configuration. We can call a POU in there, okay. And then we have time and background. The difference between a 10 is easy. Time has more priority than the background. So first the time is executed and then the background is executed. There are some special function blocks that you want to see that can only be executed in the time and not in the background, and sometimes in the background and not in the time, but that is explained in each function block. Okay. Basically, the more important that you need to check is the ones that they have the special functionalities. For example, a P advance, or for refrigeration, there are some special function blocks that need to be called only in the background. Okay. So how do we know that our PO is calling a task? Okay, it's very simple. We can see in the POU in the task that they have a question mark. And when it's called, it doesn't have anything like that. Let me show you. Here, for example, I have called URG test in the time. But if I remove this, you can see here that I have a question mark. So this is an easy way to know if the POU is executed or not. This is only available for the program type, okay, not for the function blocks or function. Continue with this. What is missing here is the local and global. We have seen before that the rest of variables are configured in the configuration tab, and in the programming we can configure local and global. An easy way to see the local variables is by go to the POU, okay, a different POU, and see the local variables, and then we have the global bars. Let me just simply show you how this is work. So we have by standard, by default, we have these global bars, okay, that we can create and use in our project, just like this, drag and drop, and in this case it's a just create a boolean. There we go. It was a different type. Drag and drop and use it in the program. If you're gonna local variables and no name, for example, in this one, we are right now in the init, and now we're gonna try to use this no name, which is a boolean, in the test to use it in init. And we are not gonna allow to do this, okay? Even if we can't do this, we're gonna receive an error, okay? This is because the local variables must be only used in the period that was declared. So if, for example, let me just, no name is created, let me just call this variable here, we can drag and drop and call init in here. I'm gonna delete it from here. Recompile this. I forgot to delete this. Undefined call. Let me just show you. Drag and drop. I delete. So now let's test it again. Option not found. Okay, so we are not able to use local variables from a different PO. It's not allowed. If you want to do that, we need to declare this no-name in a global. So let me just open the global again. No name in here. I'm gonna delete this and compile again. We see no errors. So that's the difference. The local variables must be used in the POV that was assigned, declared. If we want to use in different POUs, we need to declare that variable as a global variable. Or if we want to get access later to that variable, we should declare as a EEPROM or status. If you want to use more globals variables to separate the variables, what we need to do is to here add new global variable group. Okay, here we go. We can rename this GBL, for example, motor, and define all the global variables in here. Okay, so continue with the presentation. We also had the possibility to equip the goal to assign a password so no one can see the content of the project. Okay. Well, let me just show you in a quick way this. For example, I have my init program, grip 1, 2, 3, 4. 1, 2, 3, 4. Okay, equipped, and I'm not able to get access to it. Okay, it has a lock in there. Now the grip 1, 2, 3, 4. Okay, good. And now I can get access to the information in there. Something important, do not forget the password. So extra tools. We can assign to the Machine Expert HVAC additional tools. Okay, for example, calculator, CMD. By simplify options, custom tools, command, and assign the complete route, and then in the tool, custom tool, we can see the command that we have in there. If we want to compile, this is something important. If we want to compile only the PLC code, we have this action. Let me just show you. This is the one I showed you before, but let me show you again. It's this one that we have in here. This allows us to compile only the PLC. If you want to compile the complete project, we can use this one, build all. Okay, so if you have further question, just give us a call or contact our technical support team to help you much better.